Yes, good evening guys to all of you. I welcome you all on this wonderful platform that is BYJU'S exam prep. So guys, today this is the third session of this revision series. And in today's session, we are going to talk about what? We are going to talk about the formula and practice session for principal stresses. And some people are knowing this chapter with the name of combined stresses or complex stresses also. So we are going to start with this principal stresses topic, where first of all we will see some formula at glance, and after that we are having some practice questions as well. So are we ready? Please tell me in the comment section that am I properly audible and visible to all of you or not? Please tell me that. Please tell me guys. Then we will start it. Okay guys, so we are starting it now. Everybody. Yes, Malesh, good evening. Darshan. So we are starting guys here. So my dear, first of all, this is some detail about me, and today's topic is strength of material. This is the Telegram channel Mechanical by Dheeraj Sardana. You can join this to have the PDF of this session, handwritten notes from my side. Dhanesh Gupta, hello dear, how are you? So guys, now we are moving further. So first of all, this is the uniaxial loading which we have studied in the first chapter. But because of this uniaxial loading, if you want to see the stresses at an oblique plane, then my dear, everybody would be aware that this P can be divided into two forces. One is normal, other is shear. Okay, normal is said to be Pn, shear is said to be Ps. And I feel everybody know Pn can be written as like, you know, this is the P force. If you want to write this in this manner, this is going to be the angle of theta. If this force is P, you know that this component will be Pn, this component will be Ps. And I feel, you know, if this angle is theta, this angle will also be theta. So Pn will become P cos theta, Ps will become P sin theta. Okay. So my dear, then we have also calculated the values of normal and shear stress. Nirmala, okay. Hello, Mani, okay. Engineers, hello dear. So you know this is P cos theta, this is P sin theta. Because of that, when you find out the stresses, the normal stresses are coming out to be P by A cos square theta. And you know that shear stress will be coming as equals to P upon 2A sin 2 theta. So you can see the loading was uniaxial, but at some oblique plane, we are having normal and shear both type of stresses. Yes, Veera bhai, good evening. So my dear, we have applied the uniaxial loading, but at some oblique plane, we are getting both normal and shear stresses. And when you will be going for three cases, when you will put theta is equals to 0, you know cos 0 is 1, you will get sigma as P by A. And when you will put 0 here, you will get tau s as 0. Similarly, when you will be going for case 2, putting theta 90, cos 90 is 0, you will get 0 here, and shear will also be 0 because sin pi is also 0. Similarly, when you will go for case 3, theta 45 will give you P by 2A as normal stress, P by 2A as shear stress. Yes, Samir, good evening dear. Okay, so there is a question I feel. I have given gate 4 times but still not qualified. Could you tell me, should I prepare or not? Actually, my aim is to do MTech from IITs or NITs only. Amar, I feel if you want to go only for NITs or IITs MTech, it is very easy, because even if you qualify the gate, you will get the chance to do that. So you are talking about qualifying, which is very easy. You need some good strategy for that. Okay. You just joined my Telegram channel. I will share you my contact number. Call me. Okay, call me on Saturday, Sunday. I will give you the strategy by which very easily you can crack the gate examination. Okay. So now we are talking, guys. So we are having that both the stresses are coming, and you can see both the stresses are function of theta. So my dear, if you are talking about any plane at an angle of theta, as the theta will change, plane will change, stresses will change. What do you mean by that? At every plane, stresses are different. So we are not bothered about the stresses at all the planes. We are bothered about the stresses. Stresses which are maximum in magnitude, because failure happens with the maximum stresses. Brijesh, these classes are helpful for every engineering student who is related with mechanical or civil branch. Okay. So my dear, whenever we are talking about this P by A cos square theta or P by 2A sin 2 theta, putting these three values, we are getting some results. So my dear, now we are getting some wonderful planes here where shear stresses are 0. We are getting some planes here where shear stresses are 0. So the plane where shear stresses are 0 are called as principal planes. Okay. And the value of normal stresses at principal planes are said to be principal stresses. If you see, cos square theta can be varying from 0 to 1. So principal stresses are nothing but the minimum and maximum value of normal stresses. So you can say on principal plane, normal stresses are principal stresses. So this is principal stress 1. This is principal stress 2. So you can see these are nothing but the minimum and maximum possible value of normal stress. What do you mean by that? If you find out the normal stress at any plane, the value of the normal stress will be lying between these two values, that is sigma n, lying between 0 to P by A. So guys, this is the meaning of this discussion. When we go for shear stress, you will be getting shear stress maximum as P by 2A at theta 45. So such planes are said to be plane of maximum shear. On principal plane, we are getting shear stress to be 0, but on plane of maximum shear, on the plane of maximum shear, normal stress may be 0, may not be 0. Okay. What is the meaning for transformation of stress and strain? Samir, actually what happens is, like in this given figure, we are given the forces or stresses in this direction. But when we are taking any oblique plane, if you will see, you will not be able to see any force here. But because of force acting on this, stresses will induce on this plane also. So when you are going to find out the stresses induced on an oblique plane on which that loads are not applied directly, it is given the name of transformation of stresses. Okay, everybody is getting it. So my dear, you can see that if first principal plane is at 0 degree, second principal plane is at 90 degree, third is at 45, which means that principal planes are always making an angle 90 degree to each other, and they are making 45 degree to the plane of maximum shear. If you talk about three-dimensional, then if this is the direction of principal plane 1, this is the direction of principal plane 2, this is the direction of principal plane 3, then my dear, we will be having the maximum shear stress planes at 45 degree to the principal plane. We will be having the maximum shear stress plane at 45 degree to the principal plane. We will be having maximum shear stress plane 45 degree to the principal plane. So likewise, we will be having three principal stresses, and in every plane of principal stress, we will be having maximum shear stress also. Sir, how to prepare for ESE non-tech? Mahindra, for that you know how to prepare. You have one way. Actually, there are some marathon sessions available on this channel. You can watch that. But otherwise, it will be requiring the intense study. BYJU'S exam prep is running courses for non-tech paper 1 ESE. Okay. Because otherwise, it is very hard to study from the books. But still, if you want, on the online Google, notes of ESE paper 1 are available. You can download that and you can follow those materials to prepare for ESE paper 1. Now let us come to the point. So I already told you, whatever be the nature of applied loading, induced will be normal and shear both. Both normal and shear stresses are coming, but they are depending on theta. As theta will change, value will change. The planes for which shear is 0 are principal plane. On principal plane, normal stresses are found to be maximum and minimum. Two principal planes are oriented at 90 degree to each other. And guys, the plane at which shear stresses are found to be maximum are said to be plane of maximum shear. At the plane of maximum shear, normal stress may or may not be 0. So my dear, as we are going for revision, I am going little bit faster. This is not the class where I am teaching you from the basic. We are going with revisions. Okay. Amar, you joined my Telegram channel. Telegram I will share with you. Okay. The Telegram name is Mechanical by Dheeraj Sardana. Okay. So my dear, the plane for which shear stresses are non-zero, normal stresses are 0, are said to be plane of pure shear. plane of pure shear are special kind of plane which are always do not existing. So right now we will not be talking about those. Right now we are talking about only principal plane and plane of maximum shear. So we are moving further, guys. Now previously we were talking about uniaxial loading. Now we are talking about combined loading. If normal and shear stresses are acting together, we call it as combined loading. Actually, let us assume we are having a member which is subjected to some axial loading, subjected to some twisting moment, subjected to some bending moment. So after all this loading, if you are going to see the stress at a particular point, let us say I am going to see the stress at this particular point. When you will see the stress at this particular point, you can see this is a small point. When we are going to see the zoom view of this point, then my dear, zoom view of this point will be looking like a rectangle in 2 dimension, cube in 3 dimension. So my dear, so Amar, you will ask me there. Tomorrow I will provide you mobile number, and on Saturday or Sunday you connect with me. So guys, let us say when you see this point is subjected to some normal stresses like this. And this normal stress, we are denoting it as sigma xx. In the first chapter, I already told you why this is sigma xx. This is sigma yy. This is sigma yy. Then we have shear components as tau xy and tau yx. Okay. So guys, in the revision series, we will be going fastly. So this type of loading is said to be combined loading, where normal and shear are acting together. Now, my dear, we want to find out the stress at any oblique plane which is making an angle of theta anti-clockwise with the x phase. On that class already taught to you that this is said to be x phase because it is perpendicular to x axis. This is said to be y phase because it is perpendicular to y axis. So my dear, if you are talking about this plane will be having some normal stress, some shear stress. So let us assume the normal stress acting on this plane is this one. Shear stress is acting like this one. So normal stress I am denoting with sigma n or sigma theta. Shear stress I am denoting it with tau s or tau theta. So now whenever we will be deriving the expressions for them, they will be coming like this. First of all, I am giving you expression for sigma theta. It will be coming like this. This is sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 cos 2 theta plus tau xy sin 2 theta. But you will be getting this result when theta is in anti-clockwise from x phase. That is the necessary condition for the proof. And my dear, if by chance theta is given clockwise, then you need to put theta is equals to minus theta in this expression. Similarly, like we derived sigma theta, we can derive tau theta also. Tau theta expressions will be coming like this. Sigma xx minus sigma yy by 2 sin 2 theta minus tau xy cos 2 theta. Okay guys, then my dear, when we will be getting these expressions, then my dear, we will try to find out the relation between sigma theta and tau theta. The relation between sigma theta and tau theta will be coming like d sigma theta by d theta is equals to minus 2 times of tau theta. When you will see this relation, you would be feeling very, very happy because all the doubts are going to clear from here. You can see it is looking like dy by dx. You know, when dy by dx will be 0, y will be maximum. So my dear, you can see y will be maximum or minimum when dy by dx is 0. Similarly, we can say sigma theta will be maximum or minimum when d sigma theta by d theta is equals to 0. But this is also equals to tau theta, so when tau theta is equals to 0. That is why we get the principal planes. That is why we get the maximum and minimum value of normal stress when shear stress is becoming equals to 0. Because you can see this is equals to tau theta. That is why at principal plane shear stresses are 0. And my dear, at shear plane of maximum shear, normal stress can be anything. Because the relationship is dy by dx. That is equals to tau. That is why it is happening actually. I feel everybody understood now. Then my dear, after that we will be talking about the next case. That is, we have derived the relation for sigma theta and tau theta for combined loading. So whatever we get for sigma theta and tau theta for combined loading, you can use for other cases as well. Like if we have sigma theta as sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 cos to theta plus tau xy sin to theta. This is the first equation we understood. Tau theta is sigma xx minus sigma yy by 2 sin to theta minus tau xy cos to theta. So if you see these two equations, my dear, you can see one more wonderful thing from here. That if in this equation I put tau xy is 0, I will get the result for biaxial loading very easily. So my dear, I will not be writing the result because you know what you need to do. You just need to put tau xy 0, you will get the result for biaxial loading. Similar to that, if you will put sigma xx and sigma yy 0, you will get the result for pure shear case. Similarly, my dear, you can derive for any type of case. प्रोडक्शन का YT पे क्लास नहीं होगा क्या? मनी प्रोडक्शन में कास्टिंग, वेल्डिंग और मेटल फॉर्मिंग का तो ऑलरेडी हो चुका है. कास्टिंग और वेल्डिंग का हो चुका है, मेटल फॉर्मिंग का नहीं हुआ है, तो बाकी बचे हुए टॉपिक का होगा, स्ट्रेंथ ऑफ मटेरियल के बाद होगा. ठीक है, इज इट क्लियर? So now shall we move on? Everybody is getting it properly, guys. So my dear, now we are moving for the planes. We will search for the principal planes because we are interested into the maximum value of stresses. So when we will search for the principal plane, then you will get the relation like this. How we will get this? You just need to put tau theta is equals to 0, or you will be putting d sigma theta by d theta to be 0. When you will do these two equations, you will get tangent to theta ps tau xy by sigma xx minus sigma yy by 2. This is giving us the direction of principal plane. Now my dear, from here you can get the value of theta p, which will give you the direction of principal planes. As you already know, principal planes are at 90 degree to each other. Why you are getting it? Because tangent to theta is having a time period of pi. So my dear, if that is the case, if you are getting for 2 theta p one value as theta 1 dash, second value will be theta 1 dash plus 180. Why you will get that? Because you know the graph of tangent will be going like this. So graph of tangent will be repeating after every 180 degree. So whatever value you will get for 45 degree, you will get once again 45 plus 180. So that is why we are adding 180. So if you want to find out the value of theta p, it will be coming out to be theta 1 dash by 2 comma theta 1 dash plus 90. It is the case. So you can also write it as theta 1 comma theta 2, but the angle between theta 1 and 2 is 90 degree. So I can say two principal planes will be at an angle of 90 degrees to each other. Is it clear? हाँ, बिल्कुल मनी, we will do that. Don't worry, we will do that. So then my dear, we will be finding out the angle of obliquity. If this is the sigma theta, this is the tau theta, and you know resultant of these two will be this, because sigma theta and tau theta are at an angle of 90 degree. Resultant and sigma theta are at an angle of phi. So my dear, resultant can be written as sigma theta का square plus tau theta का square, और ये जो phi है that is said to be angle of obliquity, and that can be written as tau theta by sigma theta. How we can write it? You can use the parallelogram law of vector addition, then you will get it. Okay, so this is how we will get it. Now my dear, we are going for the principal planes. We got it. So if we are getting the principal plane at an angle of 90 degree, we must be knowing the principal stresses. So for that, I am directly giving you the expression for principal stresses. When you will be putting theta is equals to theta p, you will be getting two principal stresses. One is maximum, other is minimum. And the formula for that will be coming out to be sigma xx plus sigma yy by 2 plus minus square root of sigma xx minus sigma yy by 2 का square plus tau xy का square. Guys, please tell me, shall I directly go to the questions now? Because these are the formulas you have already seen many number of times. Similarly, when you will be going for the plane of maximum shear, you will be getting sigma xx minus sigma yy by 2 minus sign outside divided by tau xy. Then you will be getting the value of maximum shear stress, that will be coming out to be equals to sigma xx minus sigma yy by 2 का whole square plus tau xy का whole square. And my dear, similarly, you can write down tau max can also be as sigma 1 minus sigma 2 by 2, which is also known as in plane maximum shear stress. Is it clear, guys? Very good. Okay. No issues, Vineet. You can take rest. Okay. Okay. So guys, this was about the case. Now, my dear, when we are talking about all the cases, you already know principal planes are those at which shear stress is 0. If we have a case of biaxial state of stress, you know that this case, this plane is having no shear. This plane is having no shear. So they will be acting like principal plane. So you can say directly sigma 1 is sigma 2 is sigma by 2. Okay, when sigma 1 is sigma 2 is sigma by 2, you can very easily find out the value of maximum shear stress. You know, plane of maximum shear will be 45 to the principal plane. Plane of maximum shear will be 45 to the principal plane. So you can say diagonal planes are plane of maximum shear, x and y face are the principal plane. All these things, we will go for all the type of question. Aditya, Amar, don't worry about that. Okay, fine, TPM. So guys, let us see. For this case, can you tell me what are the principal planes? We will go for the questions, don't worry. Can you tell me what are the principal plane? X face, Y face or diagonal planes? 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 Tell me. Amar, Aditya. Tell me, Amar, Aditya. Okay. Dear, first of all, this plane is having no shear. This plane is having no shear. So obviously, these X face and Y face, they are principal planes. The plane which is having zero shear are said to be principal plane. So if they are principal plane, you know that what are principal stresses? Sigma 1 is plus sigma. Sigma 2 is plus sigma, like that. Okay. But my dear, here there is a problem. What is that problem? You know that we already have found out sigma theta as sigma xx plus sigma yy by 2, as this is a special case, you know, plus sigma xx minus sigma yy by 2 cos 2 theta plus tau xy sin 2 theta. So my dear, you already know for this case tau xy is 0. If you will put the value sigma xx is sigma yy is sigma divided by 2 plus sigma xx is sigma yy is sigma divided by 2 cos 2 theta. So you can say the answer will be coming out to be sigma. So you can see sigma theta is not at all the function of theta. Sigma theta is not at all a function of theta. It means at every plane normal stress will be sigma. And if you are going to find out the tau theta is coming out to be sigma xx minus sigma yy by 2 sin 2 theta minus tau xy cos 2 theta. So you also know that when I will be putting the value of sigma xx, sigma yy as sigma, this value will become 0. So you can say this is also not at all a function of theta. So you can say at every plane shear stress will be 0. If at every plane shear stress is 0, we can say here all the planes will be acting like principal planes. So here all the planes will be acting like principal plane. So if you are talking about this plane principal, 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 this plane principal. This is an example of a college where every teacher is principal. Are you getting it? Yes. So my dear, this is an exceptional case where plane of maximum shear are also not available. That's why here you need to go with proper execution of the formula, because here every plane will be acting like a principal plane. This is exceptional case. Okay, if the same case is given in opposite manner, like this sigma, this sigma, this sigma, this sigma, that kind of state of stress is said to be hydrostatic state of stress. and that is available in the fluids. Okay, everybody got it? Amar, you got it or not? Please tell me that. Yes, Aditya, Bhakti Mark, very good. Very good, guys. So whenever we are talking about this is said to be hydrostatic state of stress. Here also all planes are principal plane. At every plane shear stress will be 0. Okay, moving further. Now we are having this case, sigma minus sigma. So for this case, when you will be going for this plane is no shear, this plane is no shear. So we can call these two planes as principal plane. If they are principal plane, they are nothing but x face and y face. They are nothing but x face and y face. And you can see this sigma will become sigma 1, this minus sigma will become sigma 2. So sigma 1 is plus sigma, sigma 2 is minus sigma. So you can find out the tau max. Tau max is nothing but sigma 1 minus sigma 2 by 2. You will be getting sigma minus of minus sigma by 2. Answer will be sigma. And I feel everybody is aware that if x and y face are principal planes, then the planes at 45 degree to the principal plane is plane of maximum shear. Plane at 45 degree to the maximum or minimum normal stress is plane of maximum shear. So we can say diagonal planes are plane of maximum shear. Plane of maximum shear. So guys, now we are moving further. This is the case of pure shear. Here you already know sigma xx is 0, sigma yy is 0, tau xy is tau. So when you will find out principal stresses with the formula, you know sigma xx plus sigma yy by 2 plus minus square root of sigma xx minus sigma yy by 2 का square plus tau xy का square. So here you will be getting principal stresses as tau comma minus tau. So plus tau and minus tau. Here many students are getting confusion that sir shear stresses will become normal stress. It is not like that, guys. It is not like shear stress is becoming normal stress. No, it is like if you are applying a 100 MPa of shear stress, then first principal stress will be plus 100, second principal stress will be minus 100. This is the meaning of that only. Okay. So my dear, for this case, the diagonal planes will be principal plane, x and y face are the plane of maximum shear. So these planes are x and y face. You can see these faces are plane of maximum shear, and as there is no normal stress acting on that, so they are plane of pure shear as well. Okay, is it clear? They are plane of pure shear as well. But if you are talking about the diagonal planes are the principal planes. If you find any difficulty in finding out, you can apply tangent to theta p. Tangent to theta p was tau xy divided by sigma xx minus sigma yy by 2. You know that sigma xx, sigma yy are 0. To theta p tangent is infinity. So theta p will be 45 and 135. So that is why at 45 first principal plane, at 135 second principal plane. So principal planes are the diagonal planes. So guys, do like and share the session. Now my dear, we will see how to plot the Mohr circle. If this combined loading case is given to us, how we will be plotting the Mohr circle. In Mohr circle, my dear, first of all you need to understand, on x-axis we show normal stress, on y-axis we show shear stress. So on x-axis we show normal stress, on y-axis we show shear stress. So here we will show sigma, here we will show tau. Okay. So my dear, this is x phase. So first of all we will write the state of stress at x phase. It is nothing but plus sigma xx because it is tensile. And this tau is anti-clockwise. So it is minus tau xy. I would like to tell you guys, this is revision going on. So we are going fastly. Okay. If we are talking about the complete class, I have also taken a complete 1.5 hours class on Mohr circle also. So if you want to go in detail, the sessions are available on this YouTube channel. This is a revision session, so we will go in the form of revision. So X phase is this, Y phase. You can see for Y phase, this is normal, this is clockwise. So clockwise is taken as positive. So you will say plus sigma YY plus tau YX. You know tau XY and tau YX are equal by symmetry. So when you are going to plot these points A and B, so you know this is point A, this is point B. If you plot this, let us assume sigma XX to be more than sigma YY. So this is sigma XX, and if I go down by tau YX, I will be getting the point A. So point A is sigma XX minus tau XY or YX as they are equal. Then let us say this is sigma YY. So I will be getting the point B, which is sigma YY comma plus tau YX or tau XY. So this is the first step. I will make the state of stress on X phase, Y phase. Then my dear, we will be joining these two. When we are going to join A and B, it will be cutting X-axis at some point. You will consider this to be the center of Mohr circle. You will take AB as diameter, C as center and plot a circle. That circle is Mohr circle. I feel everybody got Mohr circle is very easy to plot. Everybody understood this wonderful Mohr circle? Got it or not? Please tell me that. This is the Mohr circle. Okay guys, if you want to see the coordinates of center of Mohr circle, that is sigma XX plus sigma YY by 2, comma 0. This is the center coordinate. Is it clear for everyone? Is it clear for everyone? Because this is sigma XX, this is sigma YY. So as this is a revision session where we are going for formula revision, I will not be going for that entire 1 hour discussion of Mohr circle. Okay? Is it clear for everyone? There is anybody wants that discussion? Because I feel every one of us have already seen that a number of times. In this year only I have taken 2 times Mohr circle. Shall we directly go to the formula and question now? Everybody is okay with that? Anybody wants any explanation? Tell me. Okay, so we are moving ahead. We are moving ahead, guys. So this was the Mohr circle. And you can see in positive x-axis we have taken normal tensile, negative x-axis normal compressive, positive y clockwise shear, negative y anti-clockwise shear. So that is how we are going to take. So guys, we have seen the procedure of plotting the Mohr circle. I already told you the coordinate of center, and if you see the radius, this is the radius. Then my dear, radius of Mohr circle will be coming out to be the tau max value, which is nothing but equals to sigma XX minus sigma YY by 2 का square plus tau XY का whole square. Okay guys. So my dear, this is about the center and radius. You know this point will give you principal stress 1. This point will give you principal stress 2. And this will be the tau max radius, you know that. Okay. So my dear, if someone will ask you with what is this plane? This is the plane of maximum shear. And you can see if the center coordinate is sigma star, then sigma star comma tau max are the state of stress. State of stress at the plane of maximum shear. Principal plane is sigma 1 comma 0 and sigma 2 comma 0. Okay. So we can also write the sigma star coordinate as sigma 1 plus sigma 2 by 2 also. So we have 2 options to define the normal stress at the plane of maximum shear. Is it clear? Okay. So we are moving to the questions now without wasting the time. Okay. But in the PDF you will get all the points. Okay. So we are moving to the questions directly. Yes. The very first question is about to come. This is the first question. We are talking about the strain gauge rosets. So, are we ready for the questions directly now as per your request? This is the first question, guys. The rosette shown has been used to determine the following strains at a point on the surface. Epsilon 1 is 428 microns. Epsilon 2 is minus 65 microns. Epsilon 4 is 183 microns. Will you try for epsilon 3? Will you try for epsilon 3? I already have told you sigma xx plus sigma yy is equals to sigma 1 plus sigma 2. Similarly, we can write epsilon xx plus epsilon yy is equals to epsilon 1 plus epsilon 2. Similarly, we can write epsilon 1 plus epsilon 3 is equals to epsilon 2 plus epsilon 4. What do you mean by that? That if this and this are perpendicular to each other, this and this are perpendicular to each other, then the summation of normal stress or normal strain on any two perpendicular plane will remain equal. Can you tell me the answer? So Malesh, everybody, it is fine now. I am coming directly on to the questions now because major formulas I have derived for you. Formula revisions means that only. If I am going to teach everything, then it will take time. Solve it. Mani is saying the answer to be C. Malesh is saying the answer to be C. You know, if epsilon 1 is 428, epsilon 3 is 183, epsilon 2 is minus 65, epsilon 4 is, okay, that we need to find out. Epsilon 3 we need to find out. So 183 is epsilon 4. Epsilon 3 is not given. 183. So epsilon 3 will be coming out to be what? Are you getting it? Minus 310. Then the answer will be C. Very good. Very good, guys. Moving to the next question. Next question is this. Don't worry, I will share the marathon session link. Those who want to go into the detail of Mohr circle and all for them. In an elastic material, the principal stress are 2 sigma 1, sigma 1 and sigma 1 by 2. So first principal stress, sigma P1 is plus 2 sigma 1. Principal stress 2 will be plus sigma 1. Principal stress 3 is minus sigma 1 by 2. What is maximum shear stress? You know that absolute maximum shear stress is maximum of sigma P1 minus sigma P2 by 2 or sigma P2 minus sigma P3 by 2 or sigma P1 minus sigma P3 by 2. Vineet, are you there or not? Okay, Vineet have already given the answer as A. So Vineet, do you want the revision of the Mohr circle cases? If that is required, at the end of the questions, I will show you that. Okay, don't worry. So Vineet is saying A, TPM is saying C, Mani is saying C. The answer for second question is, answer is 5 by 4 sigma 1. Yes. Amar, are you getting it or not? Are you getting it or not? The answer will be C for this. You can find out absolute tau max as sigma P1 is 2 sigma 1 minus sigma P2 is sigma 1 divided by 2, comma. Sigma P2 is sigma 1. Sigma P3 is minus sigma 1 by 2 divided by 2. Sigma P1 is 2 sigma 1 minus sigma 1 by 2 divided by 2. Maximum of that will be 5 by 4 sigma 1. So answer will be C for this. TPM, yes, when they are asking the maximum shear stress developed in the member it will be absolute. In the plane, it will be in plane. Okay, so when they say in the body, in the member, for design engineer, theory of failure, for all these words you will go for absolute. This is the question from Mohr circle, guys. The Mohr circle for certain stress system is shown in the figure. The principal stresses in ampere respectively are. You need to find out major and minor, means you need to find out this value. Everything is measured from the origin. This value. If you remember the stress formula, to get the strain formula, sigma is replaced by epsilon, tau is replaced by gamma by 2. This is the strain formula analysis. Tell me the answer, guys. Do like and share the session, guys. So based on your request, I directly went to the questions. I know you are more interested in questions. But if any student who will see the recording, for them I will be sharing in the comment section the marathon so that they can revise theory also. What will be the answer, guys? This is a very good question. You can see this value is given as 250. This value is given as 250. I can help you with the geometry. What will be the half of this? It is very much obvious. Half will be 125. And this is 150. So we can very easily find out this radius, because we need to find out what? Maximum and minimum. If you get the radius, you will be able to find out everything. Try to solve it. This is the radius. Once you get radius, it will be very easy for you, because we already get the sigma star as 125. So principal stress 1 will be sigma star plus radius. Principal stress 2 will be sigma star minus radius. Very good, guys. Solve this. TPM is saying the answer to be A. TPM is saying the answer to be A. What about others? What about others? So dear, what are you getting as radius? 125 का square plus 150 का square. Malesh is saying B. Some are saying A, some are saying B. Okay. So 320.26 and minus 70.26 is correct. B is the right answer. B is the right answer. Okay. So B is the right answer, guys. So B is the right answer. This you will be getting around 195. 195.26. So I feel everybody will get the correct answer. Moving to next question. At a point in an elastic material, a direct tensile stress of 60 and a direct compressive stress of 40 are applied. So they are saying there is a plane. This is having 60. This is having 40. Okay. And they are saying find out, okay, the maximum principal stress is limited to this. Sigma 1 is 75. And I feel they are asking you what is sigma 2. They are asking you the sigma 2 value. Vineet, negative will be coming because this sigma star is 125. When you will say 125 minus 195, it will be coming out to be minus 70, na? Tell me the answer to this question, guys. Okay, TPM is saying minus 55. That is correct. You already know sigma XX plus sigma YY is sigma 1 plus sigma 2. So what is sigma XX? 60. Sigma 2 will be okay, minus 55. Answer is correct. They are asking the shear stress that may be allowed on the planes where the above stresses are acting. So the previous case only 60, 40. For this case, they are saying the shear stress, tau max, you need to find out. It is sigma 1 minus sigma 2 by 2. Tell me the answer. Tell me the answer, guys. Aditya is saying the answer to be B. Sigma 1 is we have found out. Okay, dear, for this case, you need to see it like this. Here some shear will also be there, which is not given to us. Okay, so that is not given to us. This shear is not given to us. So they are saying the shear stress that may be allowed on the planes. So we need not to find out the tau max. We need to find out the shear stress on the planes. This tau xy you need to find out. This is what you need to find out. Can you tell me what will be the answer for this? We already have seen one principal stress is 75. So sigma 1 is sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 का square plus tau xy का square. You know sigma 1 is limited to 75. Sigma xx is 60. Sigma yy is Solve it and give the answer to me, guys. Are we getting B? Yes, B is correct. B is correct. So tau xy will be. Amar, are you getting it or not? Everybody got it? Okay, that we have already calculated. Maximum shear stress, now they are asking. For the same question, they are asking the maximum shear stress. It is given. Yes. Solve it. We need to find out tau max this time. What will be tau max? Okay, tau max. Tau max is having the formula of sigma xx minus sigma yy by 2 का square plus tau xy का whole square. Xx is 60, yy minus 40, tau xy is this. You will be getting the answer to be 65 MPa. So we have completed the 6 questions here. We are left with 6 more. Question number 7 from Mohr circle again. The Mohr circle is as shown in the figure. The normal and shear stress on plane CD are respectively. This is the CD plane. So you need to tell the normal and shear stress on this. You know that this will be the normal stress. Everything is measured from the origin. And this will be the shear stress. This is the radius. Try this. Because diameter is given to us, you can find out radius. Radius is d by 2. Then you can write, if this point is, let us say P, then CP is R cos 60. You need to find out OP, which is sigma theta. It is R minus CP. And then you need to find out PD, which is tau theta. It is R sin 60. This and this are your answer. Wonderful questions, guys. Wonderful questions. Hints I am giving you. TPM is saying D. Mani is saying D. Vineet is saying D. Malesh is saying D. So dear, you can see this is the Mohr circle. We are given the diameter. We can find out the radius as diameter by 2, which will be 11,500 by 2. I feel it will be coming out to be 5750. Okay, 5750 is the radius. So you will get OP. Every distance is measured from the origin. You need to see what is this. So to find out this, you need to reduce from radius this distance. So when you will go for it, it is nothing but radius 5750 minus 5750 cos theta. And whatever will be coming, it will be negative. So when you will be going for the vertical component PD, it is simply 5750 sin 60. So you will be getting the answer for this to be 49802875. D is the right answer for this. Moving further to the question number 8. Once again, Mohr circle is given to us. The Mohr circle for a certain state of stresses is shown in the figure. The angle of obliquity you need to find out. You need to find out the angle of obliquity. Okay, you need to find out the angle of obliquity. So you know that this distance is sigma theta. This distance is tau theta. This is the resultant. Tau theta by sigma theta. Okay, I feel there is a mistake in this figure. I feel there is a mistake in this figure. This figure will be like this. This is at 1000. This is at minus 650. This is the center. And this is the radius, making the angle as 60 degree. When we are talking about angle of obliquity, you know this distance will be sigma theta. This distance will be tau theta. And this will be the angle of obliquity. So tangent phi will be tau theta by sigma theta. That you need to find out, guys. Okay. So I feel if you see this value as 1000, this value as minus 650, you can find out the diameter as 1650. Radius will be 1650 by 2, 825. Is it clear for everyone? Radius will be 825. You know, this is radius. Now what is center coordinate? It will be sigma xx plus sigma yy by 2 or sigma 1 plus sigma 2 by 2. We know sigma 1 is 1000, sigma 2 is minus 650. Minus 650. This will give you sigma star. Once you have the sigma star, then sigma theta is sigma star plus r cos 60 degree. Because this is the radius, r cos 60 degree. When you will add into this, you will get sigma theta. And tau theta is r sin 60 degree. Guys, this type of explanation, this type of question, you will not get anywhere else. They are dangerous one. I have made it very, I know the class timing is very odd. That's why I need to skip the formula revision and directly come to the questions. We are studying at midnight. So you will be getting the sigma theta. First of all, tell me the value of sigma theta, guys. What is the value of sigma theta? You know 1000 minus 650 will be 350 by 2. 175. What will be 175 plus radius is 825 cos 60. What is sigma star? 587.5. What is tau theta? Sigma theta is 587.5. What is tau theta? Tau theta is tau theta is r sin 60. R is 825. Okay, so theta phi is tangent inverse tau theta by sigma theta. Answer will be 50.5 degrees. Very good, guys. Wonderful. Moving further. Anybody have any doubt? You can please ask. Anybody have any doubt? You can please ask. Very good. The data obtained from a rectangular strain gauge rosette, epsilon 0 degree, epsilon 45 degree, epsilon 90 degree. Young's modulus is this. Poisson ratio is 0.3. Calculate the values of principal stresses acting at the point and their directions. You only find out the principal stresses. I will tell you how to go with. First of all, epsilon 0 degree is your epsilon xx. Epsilon 90 degree is your epsilon yy. So you can say gamma xy is 2 times of epsilon 45 degree minus epsilon 0 degree minus epsilon 90 degree. After getting all these things, you can find out principal strains. Xx plus yy by 2 plus minus xx minus yy by 2 का square gamma xy by 2 का square. This will give you the principal strains. Then you know principal stress E upon 1 minus mu square epsilon 1 plus mu times of epsilon 2. Sigma 2 will be E by 1 minus mu square epsilon 2 plus mu times of epsilon 1. So today I am having slightly hard questions because I expect you guys also expect the same from me. Because easy question now you will be able to make by your own also. Try this. I hope everybody will be giving the right answer for this. Great, Amar. Solve it. Give the answer. Money, actually the problem is I am busy from 6 to 11 as I have classes from 6 to 11. So either we can have class in the morning or in the midnight. These are the two options. Or we can have the classes on Saturday, Sunday. So we will try ki major classes would be on Saturday, Sunday on the normal timings. Okay. So from the next week, I will try to have the classes majorly on Saturday, Sunday and 1 to 2 class if possible in the Monday to Friday, either morning or evening. Okay. That 5 to 6 p.m. can be done. Okay, no issues. We will try to keep majorly on the weekends. As you know, mathematics is also going on Sunday. So we will try to keep the technical session also like that. Tell me the answer for this question. Tell me the answer for this question. But what I found is you guys are more interested into questions rather than conceptual or theory part. So if you will clearly say, it would be better we come up with practice sessions and conceptual questions only, conceptual sessions only for some particular topics. Solve it. Very good, TPM. The answer is correct. But I feel you have made some mistake. Yes, Abhishek. So are we getting 385 or 38.5? Are we getting 385 or 38.5? Please tell me. 385 or 38.5? $38.5 will be the answer. Okay. So you can see this is epsilon 0, epsilon 45, epsilon 90 is given to you. You need to use these formulas and answer will be coming out to be 38.55. So this is the case when Mohr circle will become a point. This is that case. Everybody is aware? Wonderful, guys. Moving to question number 10. This is one of my favorite type of question, where we have a circle of diameter 50 mm is inscribed on a square plate. This is a square plate on which this circle is inscribed like this. Before the application of the stress as shown in the figure. After that we applied the stresses. After that we applied the stresses. And what are the stresses? 160, 80 and 30. After this circle is changing into ellipse. So what is the difference in circle and ellipse? In circle, all the diameters are equal. But in ellipse, this is major dia, this is minor dia. All other dias are lying in between. So in the question, they are asking us the major and minor diameter. So you know, if this circle will be taking the shape of an ellipse, the major dia will be coming at the maximum principal plane. The minor dia will be coming at minimum principal plane. So you just need to find out first of all the principal stresses sigma 1 and sigma 2. For that you know the formula sigma 1 comma 2 as xx plus yy by 2 plus minus square root of xx minus yy by 2 का whole square plus tau xy का whole square. You will get sigma 1 and sigma 2. After getting sigma 1 and sigma 2 values, you can find out epsilon 1. What will be epsilon 1? Sigma 1 by E minus mu times sigma 2 by E. What is epsilon 2? Sigma 2 by E minus mu times sigma 1 by E. Epsilon 1 is delta D1 by D. Epsilon 2 is delta D2 by D. When you will be adding D plus delta D1, it will give you the major diameter. When you will be go for D plus delta D2, you will get the minor diameter. These will give you the major and minor diameter of the ellipse. That will be your final answer. Try this, it is a wonderful question. Okay, so TPM is saying 59 point. No, Vineet, TPM, both of you are wrong. You have made some mistake. Yes, major diameter and minor diameter, when you have found out, TPM, your minor diameter is correct, major is wrong. First of all, find out sigma 1 and sigma 2. What are the values of sigma 1 and sigma 2? First of all, find out sigma 1 and sigma 2. Find out sigma 1 and sigma 2. Abhishek, are you there or not? Abhishek Shivam. Yes, now your answer is correct, TPM. सर HAL इंटरव्यू पर भी प्लीज कोई वीडियो बना दो, 9 अक्टूबर को है. अभिषेक, डू यू वांट द मॉक इंटरव्यू? If you want, we can arrange mock interview for HAL for you. If you want on the online mode, we can try for that. Okay? You connect with me on the mobile separately. We will plan a mock interview for you. Okay, so guys, when we are getting this, you will get sigma 1 value as 170, sigma 2 value as 70. Okay, and principal strains as 1455, 1455 and 105 microns. Then you will get 500.72, 500.0525. Is it clear, Malesh? Have you done it? Malesh, have you done it? Okay, guys. So these two questions are homework for you. These two questions are homework for you. Okay. You can download the app. You can also join my Telegram channel to get the PDF of this session. Okay. And these are two homework questions for you guys. Okay. I will share their solutions also with you. Is it clear? Yes, Vineet. So guys, I want to ask you, do you want only practice sessions? Then why we are having the theory sessions? Because in the theory you guys are saying, sir, directly go to the questions. So why we are wasting time in the theory then? How many of you want only question sessions? I want to know from your side. If you are interested only in questions, why we waste time into the theory? आधी आधी बातें नहीं, या तो कॉन्सेप्ट और क्वेश्चन. ओके ओके गाइस, सो now okay, fine. Okay, you want only formulas, not the concepts. Okay, I got that. So guys, now Vineet, you were asking about the Mohr circle of the special cases. So it is very easy to plot the Mohr circle of special cases. If you want to see that, like you have this case. On X face, we have sigma comma 0. On Y face, we have sigma by 2 comma 0. So this point will be sigma comma 0. This point will be sigma by 2 comma 0. You will join them, take AB as diameter, you will plot the circle, and this will be the center of Mohr circle. Similarly, if you have this as sigma, this as sigma, X face will be sigma comma 0, Y face will be sigma comma 0. So you will plot A and B both here, C will be center here, taking AB as diameter, plot the circle will be a point. Okay. So majority of you are in the favor of questions only. If you have this sigma and this sigma, then you have sigma comma 0 as A minus sigma comma 0 as B. So one point will be here, other point will be here. You will join AB, C as center, take AB as diameter and plot the circle. This will be the Mohr circle. Okay, fine guys. So today I am leaving here. We will meet again day after tomorrow. Okay, so goodbye for this particular session. Good night. Thanks for your love and support. Before leaving the session, do like and share. I will share the PDF with you along with the solutions. Okay, Vineet, we will plan it soon, don't worry. Okay. So we will go for formula revision, not the complete discussions. Goodbye.